Wind turbine blades are getting bigger and bigger, and they are installed more in the offshore environment, where hurricanes, typhoon, and tornadoes are not unusual anymore. Wind turbine blades are designed usually to survive the extreme load, which are typically applied to them statically. But are they strong enough to survive the extreme dynamic loads, which happen in the real world? The Discoverblade project will answer this question by conducting the world's first full-scale destructive testing. Here, we intentionally break the blade under extreme dynamic loads, which is to mimic the typhoon events. And we want to see why and how the blade will fail under such extreme condition. And here we have a unique opportunity to test the blade to collapse in a very controlled way. And we have a lot of advanced measurement technique around it. And we gather a lot of valuable data to get the insight of the blade failure.
Doing experiments on very large blades to extreme failure is very expensive. So we have unique opportunities here to test downscale versions of blades. So what we have done in this project is to do a kind of downscale version of the DTU 10 megawatt reference rotor, which is then downscaled to 12.6 meters. And when subjected to the fatigue loading, it has the same strain distribution as the reference rotor. The blade is manufactured in our blade lab. It uses the same mold tools as used for the 12.6 meter DTU blade. The internal structure consists of two shear webs which are glued to the monolithic load-carrying laminate known as the spar caps. The hypothesis is that it's a combination of the very high mean load and a minor damage propagating, which led to a total collapse of the internal structure of the blade.
In terms of load, we used a really nice paper of our colleagues from US who actually placed this 10 megawatt reference turbine into a 5-category hurricane. They processed it with the rainflow counting and derived the equivalent loads for this particular case. Then we simulated the test, so we scaled down the loads from 10 megawatt reference, which is 86 meter long blade, to 12.6. And the main focus, as you can see here, was on obtaining the mean load and also trying to follow the range where we can follow it. And then simulation showed that at 6 meters, where the more or less blade failed, strain can reach minus 6,000 microstrains.
This project provides us a unique opportunity to obtain the fundamental knowledge to develop the future structural model that can predict this kind of failure under extreme dynamic loads, and also develop a more damage tolerance manufacturing design method that can potentially reduce the large-scale structural failure of the offshore wind turbine blades, which are installed in the harsh offshore environment.